right, so what has to be done right here on this piece? Product rule, so that's first. Times the derivative of the second. What's the derivative of e to the negative x? Perfect. Plus the second times derivative of the first. And then minus that derivative. What's it going to be? It's going to end up being plus 3e to the negative x. Very good. All right, raise your hand if you can help me do the next step. Ethan?
Did you square out and e to the negative x?
Say that again. Okay, yeah, factor it out. So I'm actually going to do a negative e to the negative x. So that makes it x squared minus 2x minus 3. All right, Hunter, what's next?
You set the whole thing equal to 0, and then you set each separate one equal to 0. And e to the x equals 0, so you can just like...
Very good. No need to set that equal to 0. It can't be 0. X squared minus 2x minus 3 turns into what?
X minus 3 and x plus 1.
Okay, so we end up with 3 and negative 1. Good. Jennifer, what's next? Sign line, good. So negative 1 and 3. Plug in 0. Now make sure you plug in right here. Okay, or you can replace that, but this has to stay here. That has to be part of it. Okay, so if I plug in 0, 0 here gives me a negative, 0 here gives me a positive, and 0 here gives me a negative. So I got two negatives and a positive, so that means that section is
Negative.
positive. Okay, and if you go off of multiplicities, if you're good with multiplicities, you should know that they alternate. If you're not good with multiplicities, then just plug in. So if I plug in 4, positive, positive, negative. So I get a negative. Okay, this thing right here is always going to be what? Negative. Always going to be negative. Negative 2, negative, 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 3 negatives gives me a negative. Okay, and this once where we are increasing, so that means I'm looking for my sign line to be positive, and that happens in between negative 1 and 3. Good stuff. All right, raise your hand if you have another question. John Ryan?
Number 10.
All right, so which graph are we looking at? Graph of f. So make sure you identify which graph it is, because sometimes they might give you f prime, sometimes they're going to give you f. So make sure you pay attention to that. What does it mean when they tell you it's twice differentiable? You can take the first and second derivative, so you're good to go there. All right, who can explain how to get the answer here? Who can handle that for me? All right, go ahead. Yes, you.
Okay. So
Maddie.
f of 1 equals 0.
All right, so let's stop there. She said that f of 1 equals 0. Everybody good with f of 1 being 0?
Yes.
All right, Maddie, go ahead.
Since it's increasing, that means that the derivative of f of 1 is positive.
Very good. So she's saying since f is increasing right here, then that means the derivative is positive. Very good.
Since it's concave down, the
Double prime or prime prime
is negative.
is negative, so that's negative. So then I have a negative. So that means the smallest one is f double prime, so it's got to be down to d or e. The 0 is always going to be in the middle, so that means my answer is going to be D. Good stuff. I like that problem a lot.
But why is f double prime negative?
Okay, why is it negative again?
Concave
Concave
down.
down.
How do you tell that?
Because of the curve.
Concave down.
Concave down like a frown, concave up.
So you're just kind of inferring that it's like, it's gonna go back down.
Say it again.
Just kind of looking at it and saying it's gonna go back down eventually. With that graph.
Well, it's either going to look like this or it's going to look like that. We've got to understand that this over here on the left is down and this is up. If you can draw a U with it, it's up. Okay, if you kept going with this, I'd be able to draw a U. If I kept going with that, I would not be able to draw a U.
So say from the end point of the line to like the beginning point to the end point, it's concave down. But when it switches to start going up, that becomes concave up then.
All right, raise your hand if you have another one. Ethan?
Is there an easier way to find out number 12? Easier way to find out number 12.
What do you mean by easier way? What did you do?
Well, I did like the power rule and then the product rule.
Yep.
That's just it.
Anybody need to see this one? All right, so we need critical points. Where do you get critical points from? First root of 0 or undefined. And now that I'm doing this, I think I've selected the wrong answer. All right, so derivative is going to require product rule. So first, derivative of the second plus the second derivative of the first. Everybody good with that point? Okay, what do we want to do next?
I said we could factor out x plus 2 to the fourth and factor out x minus 3 to the third.
All right, so we have x plus 2. We have x plus 2. You can always factor out the smallest one. So the smallest of those two is x plus 2 to the fourth. Okay, then we have an x minus 3 and an x minus 3. The smallest of that is 3. So I have an x minus 3 to the third. So that's gone, that's gone, that's gone, and that's gone. So now it's just a matter of putting everything that's left inside of one parenthesis. So I'm going to go ahead and distribute this here. So that gives me 4x plus 8. And distribute this here. So that gives me 5x minus 15.
Wow, how do you get minus 3 cubed?
Because I had an x minus 3 cubed here, and I had an x minus 3 to the fourth. You can always factor out the smallest. Just like if I had 2x squared plus x cubed y, what can I factor out?
You can pull out the x cubed.
I can pull out an x squared.
Okay, so how do you leave an extra x there?
Say it again.
If you pull out the x minus 3 cubed, how is there still an x there?
Are you talking about on this one?
So the 4x.
Here?
Yeah.
Because I went 4 times that and 4 times that. Alright, so f prime of x equals x plus 2 to the fourth, x minus 3 to the third, and 9x minus 7. At this point, you can answer the problem. What's the answer? 3. Because I can set all 3 of those equal to 0 and get an x value. Therefore, I've got 3 critical points. All right, now answer me this, though. How many extrema will there be? And why?
5.
I can't have any more extrema than I have critical points. So the max number of extrema I can have is 3. So 0, 1, 2, or 3 are my options here. How many extrema will I have and why?
I'm gonna put it on the sign line.
What?
I said put it on the sign
I
line.
could put it on the sign line and do that. That's one way to do it. But you should be able to tell without doing a sign line.
Would it be 2?
Why?
You couldn't do x minus 3 cubed, could you?
Yep, you can do that.
Okay, never mind.
I was
Hunter?
gonna say it'd be 3 because it's 2 relative extrema because there's 2 negative and 2 positive or 1 positive.
Nope.
No.
Roshan?
Is it 3 because a number makes equal 0?
No, it's 2. 2 is the correct answer, but why is 2 the correct answer?
Well, they changed sign.
They don't change signs. It changed signs here, and it changed signs here, but that one does not change signs. Why does that one not change signs? It's got an even multiplicity. If you have something with an even multiplicity, it's not going to be an extremum because the signs aren't going to change. Okay? So I can look at this and automatically know there's going to be 2 extrema. Or if I'm like I said before, if I'm not good with multiplicity, then as Mallory said, put it on a sign line. You can figure it out that way. But if you're good with multiplicity, then you save yourself quite a bit of time. All right, so I have -2. I've got 7/9, and I have 3. Okay, so we'll start over here with -3. Regardless of what I put in here, this is always going to produce a positive because of that 4. Okay, so -4 here is going to be negative, and negative here is going to be negative. So those 3 combined to give me a positive. Okay, easy thing in between here. 0, positive, negative, negative also gives me a positive. Plug in 1, positive, negative, positive. So positive, negative, positive gives me a negative. Plug in 4, positive, positive, positive gives me a positive. Notice it changes at 3, it changes at 7/9, does not change at -2 because -2 had an even multiplicity.
Why wouldn't you write relative max? Relative max.
I'd have a max here, I'd have a minimum there.
Can you tell if it's a max or a minimum?
You cannot tell if it's a max or minimum there. You can just tell how many extrema you're going to have.
So we can write relative max from.
There's no from. Relative maxes occur at a specific location.
Okay, never mind. That's not what I'm trying to say.
Okay, but in this case, it only wanted the critical points, so my critical points are 3. Now, what ends up happening at -2 since it's not an extrema? Point of inflection. It's going to be a point of inflection.
What about when you wrote like relative min, parentheses, negative infinity to 0 or whatever?
We don't do that. That's decreasing or increasing intervals.
Okay.
If I want a min or a max, it's got to be at a specific spot.
Can you do it's like relative min is 26 at x equals 7? Okay, that's what.
All right, what else you got, Elite?
18.
18. All right, what are we using here on 18? L'Hopital's rule. L'Hopital's rule. Number 1 rule when you're finding a limit, though, is plug in. So if I plug in 0 here, I have 0. So that's going to be 0 on the top. And we all know that sine of 0 is also 0. So L'Hopital says take the derivative of each piece. So derivative of x times tangent requires product rule. So that's first. What is the derivative of tangent? Secant squared. Plus the second times derivative of the first. And on the bottom, derivative of sine of 3x. 3 cosine 3x. Do not forget to take the derivative of that inside piece. Don't forget that. And we're still approaching 0. Alright, so now what do I do?
Plug in 0.
Plug in 0. So when I plug in 0 here, that turns into 0. When I plug in 0 here, tangent of 0 is also 0. So my top is 0 again. But in the bottom, what's cosine of 0? 1, and 1 times 3 is 3. What is 0 over a number? 0. So that means the limit of this original function is 0. John Ryan?
What if you were to get a number over 0 on a problem like that?
Then your limit's infinity
Okay.
Wait, you wouldn't just keep
or
finding.
negative infinity.
If you got a number over 0 with the Hospital's rule, you wouldn't just keep going?
No.
Second derivative?
No, it's got to be 0 over 0 or infinity over infinity.
So you don't go to the second, you don't go to second.
The number over 0 is infinity or...
It's going to be infinity or negative infinity. You'd have to do some checking.
What happens if it's infinity over 0?
That's what they were just saying. Or were they saying that?
They're saying no.
This says it flips.
I don't know about infinity over 0.
I don't think I was on
No, infinity over 0.
Wait, what's the thing? How would you want like a number over infinity and infinity over a number?
Infinity over a number is infinity, but a number over infinity is 0. All right, what else? Abby?
Oh, I forgot you were in here. Sorry.
It's okay, we're being recorded. You want to say hi to here? 57.
No, somebody asked for 17.
I didn't know somebody just asked.
All right, 17. Plug in infinity. The numerator is going to be infinity. The denominator is going to be infinity. So we can use L'Hopital's rule. So that's going to give me, what's the derivative of the numerator? 1 over x. And derivative of the bottom, 2x. So what does that reduce to? Well, I need to clean this up before I plug in infinity. What is that when you clean it up? 1 over 2x squared. Okay, because remember, that's the same thing as 1 over x divided by 2x. What does the division symbol tell me to do? Multiply by the reciprocal. And that's where I get my 1 over 2x squared. Okay, plug in. I get 1 over infinity, which we know is 0. So my limit is 0.
Are you going to count off if we don't?
If you don't what?
If we don't clean it up, are you going to count off?
So what did you do? Make this 0 over infinity and then went to 0? Yeah, that's fine. All right, Mallory, what do you want?
7.
You can be next, right?
No, it's not. It's a question about this problem.
What is it?
You said you never keep going on the Hospital's rule. Like, if say
That's
you
not
get
what I said.
Oh, I was asking. I thought
You're
that.
talking about a specific thing.
Oh, I mean, like, if you say you get 0 to 0 again when you find the first derivative.
Yes, you keep going.
Okay.
But you were talking about a specific one, and if you get to that specific one, you don't want to keep going. If I get to 1 over infinity or 0 infinity, I'm not going to keep going. That's my answer. If I get to infinity over a number, I'm not going to keep going.
That's infinity.
Because that's infinity or negative infinity.
You have to do infinity over infinity.
Okay. All right, Mallory, what'd you say?
7.
Questions. Did you get that, Mr. Robot? But we're going to call them next time. The camera. You all seeing that?
All right, I like 7 a lot too. All right, so we have a of x equals f of 5 minus 3x. It wants to know, is there a critical point at x equals 1? What one of two things has to happen in order for a critical point to happen?
Across the x-axis.
That's a prime.
0 or undefined. If I'm looking at a graph, yes, it has to touch the x-axis of what graph? The derivative. Or be undefined. So I need to find the derivative of this. So what is the derivative of f of 5 minus 3x?
F prime is 5 minus 3x.
So I'm going to put the negative 3 out front, f prime 5 minus 3x. So if I want to know if there's a critical point at x equals 1, what do I need to do next? I need to plug in 1. So negative 3, f prime, 5 minus 3. So negative 3, f prime of 2. What is f prime of 2? 0, and 0 times negative 3 gives me 0. So a prime of 1 is 0, so that means it is a critical point. So it is a critical point. If it does have a critical point, can you determine whether or not it's a max or a min or neither? Okay, how can we determine? We've got two different ways to determine whether or not something's a max or a min. First derivative test and the second derivative test. What's the first derivative test? Sign line, and what has to happen? I got to change signs. What's the second derivative test? Plug it into the second derivative. If it's positive, that means I have a minimum. If it's negative, I have a maximum. With what they've given me, is there any way I can do a sign line? No, there's not enough information. But they have given me second derivative information, so that means I can probably do the second derivative test. So what do I do next? Take the second derivative. So here's my first derivative. What would the second derivative be? F double prime 5 minus 3x times 9. 9 is what it's going to be. Okay? Because when I take the derivative of this, I get another 3, negative 3 with the negative 3 that's already there. That's where I get my 9 from. All right, what's next? Plug in 1. So 9f double prime. If I plug in 1 here, I get my 2. And what does the chart say that f double prime of 2 is? Negative 2. So I have 9 times negative 2. So that means a double prime of 1 is negative 18, Courtney, which means I have a max or a min.
Yes.
I have a maximum. Very good.
But if that, make sure I got this straight. If that would have been, if we're looking for absolute, that would have been your min.
If it was an absolute, I would not have messed with my second derivative.
It's not a second derivative, but like, say your value is negative. It's absolute, it switches, right? Like,
Absolute, you're looking at y values. What's my biggest y value? What's my smallest y value?
But okay, so with relative, we look at x values.
It depends on what you're doing. Relative, you're either going to look at a sign line and that's going to tell you, or you're going to look at the second derivative and that's going to tell you. Now, make sure you're paying attention, please, and I'm going to give you your quizzes back today before you leave. A lot of you, when you did the second derivative test, here's what you gave me on your answer. You said relative max is negative 18 at x equals 1. What's wrong with that?
You didn't say because a double prime.
Well, okay. Because, and I'm glad you said that, because here's something else you guys forgot to do. Okay, a lot of you just said a double prime is less than or greater than 0. You have to put this value in here. If we're talking about a specific spot, you have to put that in there. Okay, now what's wrong with this statement? Because a lot of you screwed up with what's up there. No.
Well, it's saying relative max to that. Negative.
Thank you. Negative 18 is the second derivative value. What value should be here? The y value from the original. If you're going to tell me what a max or a min is, you have to give me the y value from the original function. Okay? A value from the derivative or the second derivative just gives you information. It does not tell you what it is. You have to go to the first, or you have to go to the original to figure out what it is.
I thought like on our other worksheets we did it like absolute.
We were dealing with absolute. And it works that way with absolute because once I find the critical points, what am I doing next? Plugging in my endpoints and my critical points into the original function, which gives me the y value. So that's why I could go straight to this. But a lot of you were taking the second derivative value, plugging it here, and saying that's what the max or min is. You got to get the max or min value from the original function. Ethan?
So is this statement correct if you take out is negative 18?
If I did relative max at x equals 1, yes, my statement's correct.
So do you have to plug in?
It depends on what the question asks.
So in this one,
If it wants to know what is, in this case, does it have a max or a min? No, I don't need it.
But what would be an example when you would need to put the value?
It'll say, what's the max or min value? If it wants the value, then that means it wants the what it is.
I thought
And
you
you
said-
have to plug that into the original.
Yesterday I thought you said you would plug in your x, whatever value you plug into the sample. Say your f prime value, you plug it back into the f prime function.
Right? That tells you whether or not your derivative is positive or negative, which tells you information about f.
So then why are you plugging a value from f double prime to the original?
I'm not plugging in the value from f double prime in the original. I use the same x value throughout this whole thing. I'm plugging in the x value,
From f to f prime?
the x value they're interested in. That's what gets plugged in. So the value that actually goes here, 5 minus 3 gives me 2. I go to 2, there's 5. So that means if I wanted to put something here, that value would be 5. My maximum value, relative max value is 5.
Okay.
If you want the value, it's got to come from the original. First and derivative just tell you stuff. It tells you what's going on. It doesn't tell you what it is. So make sure you clear that up. Abby?
Can you say that a double prime of 1 is negative, or do you have to say less than 1?
Either one. All right, what else?
I'm probably more now, coach.
You did 15.
Yeah, I'm glad you did 15 because it didn't work out like I wanted to. I wanted you to take the derivative of a natural log because that's something you need to be really good at, but it ends up not working out very good. But we'll go ahead and work it. All right. So what's the derivative of this thing?
2x minus 6 over x squared minus 6.
2x minus 6 over x squared minus 6x. I definitely agree with that. That's good stuff. All right, now what?
You said it equals 0?
All right, Mallory, what's the question?
Oh, no. I got lost.
It's the derivative of the inside. It goes on top.
Okay.
And then what's inside goes on bottom.
Okay.
Derivative over original. That's how you take the derivative. All right, set it equal to 0. 2x minus 6, x squared minus 6x. Then what?
Set the top and bottom.
Set the top and the bottom equal. So 0 equals 2x minus 6. 0 equals x squared minus 6x. So this one's going to give me x equals 3. Over here, take out an x. So I get x equals 0 and 6. Now, anytime I have a fraction in my derivative and I go to get critical points, what do we have to be leery of?
If it makes the original also undefined.
All right, so if you have a critical point that comes from the bottom, you have to make sure it does not cause problems in the original function. So I need to plug 0 in here. So I have 0 minus 0, so that gives me the natural log of 0. Is there an issue with the natural log of 0? Yes, because I can only take natural log of what? Positive values. So that means 0 is no good to me. Do the same thing with 6. Plug in 6. 6 squared is 36 minus 6 times 6, which is 36. 36 minus 36 is 0. So that one is no good. But, so I have to be careful when I have derivatives that are fractions. However, if I'm dealing with a natural log, I've got to check all of my values and make sure they don't cause problems. Because what happens when I plug 3 in here? I have 9 minus 18, which is negative. So that's not a critical point either. So in this case, no critical points. No critical points, which means no extrema.
Yes. I thought it's only the bottom ones that have to go back into the top.
If it's a regular function. The fact that it's natural log, you need to check your critical points because there are domain issues with the natural log.
But if it was like a regular limit, it would be fine.
If this started out as a different function, then yes, this would have been a critical point, and I wouldn't have had to check it. But since it's a natural log, you need to check everything and make sure you don't have an issue.
That's a lot though. Really?
So it didn't turn out the way I want, but it's still good stuff. It still reminds you that you got to check when you're doing natural log.
You're annoying.
Video on YouTube.
Not on YouTube. I'll send it on Remind. All right, what else? We We've got 10 minutes left.
8.
8.
Yeah, can we do 9 too?
Yeah, 3 to 9.
Oh wait, no, I did finish
All right. Eight's some good stuff. I like this problem a lot. Now notice we are looking at the first derivative. Okay, and we're wanting to know which one of these, what type of functions are these that are graphed over here? What are they? They are f. So I'm looking at the first derivative and I'm wanting to know which one of these graphs could be the actual function. So what are some things we can learn from the first derivative that are going to help me match f? John Ryan?
Like where it's positive and negative to tell where f is increasing and decreasing.
All right, positive, negative to tell where f is increasing and decreasing. All right, so right here, what does that mean I'm doing?
You're decreasing. You're negative.
The derivative is negative, which means f is decreasing. So on the left side of negative 2, I need to be decreasing. Which one of these graphs is not decreasing on the left side of negative 2?
B, D, C.
A is no good. C is no good. D is no good. Everybody understand? Because what is this function always doing? Always increasing. What is this function doing right here? Increasing. What is this one doing? Increasing. And this derivative tells me that it's got to be decreasing. Okay? So this middle section, the derivative is positive, so what must be happening? I got to be increasing in the middle. Okay? Well, what is this one not ever doing? It's not ever increasing, so that's not it. That's got to be my answer. Now, yes.
How would B work?
Say it again.
Oh, I'm looking at I was reading it wrong. I was not reading from left to right. My bad.
All right, now what John Ryan did there, he was looking at increasing and decreasing. That worked for this problem. Sometimes that works, but it's not the most efficient way of doing it. What else can the first derivative tell me besides whether or not we're increasing or decreasing, Hunter?
I was going to say, I found it because I just found the minimum and maximum.
There you go. First derivative can tell me where my mins and maxes are. What am I looking for to find mins or maxes? Where it changes signs. So we change signs right there, and we change signs right there. How do we change signs there? Negative to positive, so that means I got a minimum there, and right here I have a max because I'm changing from positive to negative. So I need a minimum at negative 2 and a maximum at 2. Notice, minimum at negative 2, maximum at 2. Okay? So that one's probably a little bit quicker. Now, sometimes that won't give you enough. If that doesn't give you enough, then you go back to, all right, where is it increasing, where is it decreasing, and you'll eventually find the match. Anything else on this one? This one's good stuff. It is. I agree.
all the problems.
Just because often on the book and stuff.
All right. Somebody asked for 9. All right. Relative extrema. What do? Find the derivative, quotient rule. So bottom, derivative of the top, minus the top, derivative of the bottom. And what a lot of you forget to do is the bottom squared. So when I square that, that turns into 6. All right, what's next?
Factor out an x plus 4 squared and cancel.
All right. So factor out an x plus 4 squared. So that goes away. That goes away. So this and this are left. So that gives me 2x plus 8 minus these two are left, which gives me 6x. Okay. Then he said reduce, which gives me that. So I end up with negative 4x plus 8 over x plus 4 to the 4th. Okay, so what are my options from here? Yeah, I need to set it equal to 0 and get my critical points. After I get my critical points, what are my options? That's where I meant to go with it. Second derivative to do second derivative test or sine line. Okay, look at what you've got here. Is it going to be easy to do the second derivative? No, so what do I want to do? I want to do a sine line. And after I get finished with this problem, remind me to tell you something. I have a recommendation for you.
Why didn't we do sine line on that other one again? That we just didn't.
Because it said use the second derivative test.
Oh.
All right, set the whole thing equal, then set each piece equal. So 0 equals negative 4x plus 8, which gives me x equals 2. 0. X plus 4 to the 4th. That gives me x equals negative 4. But where did that one come from? The bottom. So what do I have to do with it? Check it. Does it cause me issues? Yes. So this is not a critical point.
Wait, pause. So why did it cause your problem floating the top?
Makes my denominator 0. Gives me a number over 0. Causes me a problem. All right, so what's next? Sine line. Now, even though negative 4 is not a critical point, it still needs to be on your sine line. So negative 4 needs to be on my sine line, and 2 needs to be on my sine line. All right, so let's plug in 0. 0 in the numerator gives me positive. The denominator is always going to be positive. So that means we are positive. Plug in 3. Numerator is negative. So we're negative. Plug in negative 5. Numerator is positive. Okay. Again, I really don't care what's happening at negative 4 because my only critical point is 2. So what's going on at 2? Relative max. So I have a relative max at x equals 2. If I wanted to know what it is, what would I do? Plug it into the original. So if I plug in 2, that's going to give me 4 on the top, 6 cubed. I think that's 216. Is that, and what's my explanation? F prime changes from positive to negative. There it is. It just depends on what it says. Find all relative extrema, I'd go ahead and do it. Okay. It's not that hard, just plug in. Alright. If we've got a quick one, we can do one more quick one.
Wait, tell us that thing.
Oh, okay, good. Let me see if I can find it.
I'm definitely going to be.
Look on just like
I wish we got this. We just
not a
because-
German hand.
Just keep putting all this stuff. I know. It's okay. Yellow.
Alright, I don't see it, but my recommendation is anytime you have a function that has trig in it and it wants relative extrema, I would recommend doing the second derivative test. Now, can anybody tell me why I would recommend doing the second derivative test anytime you're doing a function that has trig in it? Right, because when you do the sine line, it's pretty tough to figure out what's positive and what's negative. And what's really easy to do anytime I'm dealing with trig functions? Get the second derivative. Because the derivative of sine is going to be cosine, and then I take the derivative of cosine, and then it goes back to sine. So super easy when you're dealing with trig to get to the second derivative. If it's easy to get to the second derivative, go to it. Okay? Because it's a lot easier to go to the second derivative and then plug a value in to determine whether or not it's positive or negative versus doing a sign line and then figuring out whether or not 3 or 4 things are positive or negative. Make sense? So I would recommend anytime it's relative extrema, trig function, go to the second derivative test, use that. Got it? Okay, I will again post the answers and post a video of the rest of the answers.